Hello and welcome to Module 2, During AI, Tracking the Math and Keeping It Honest. In Module 1, we focused on preparing data before it enters an AI tool. In this module, we shift to what happens while AI is actually being used. This is where many teams lose control. The file that they upload may be clean, but the process still breaks. The AI may produce an answer, but no one can explain where it came from. Or worse, the answer looks reasonable, but it is based on stale, misaligned, or even incomplete data. So in this module, we'll focus on 4 things: how to trace outputs back to the source data, how to spot data freshness issues, how to assess output risk, and then how to keep the process auditable while AI is doing the work. In this module, we're going to cover a few different areas. We're going to look at following the data trail, followed by traceability steps, and then understanding why this matters. We're going to talk about data drift, and then a freshness check that we can apply to avoid that drift. We're going to talk about output risk, and then an AI output trust framework that we can lean on to circumvent that risk. And then we're going to wrap up Module 2 with a practical exercise to put everything that we learn into practice. So how do we follow the data trail? Well, in finance and treasury, there is no such thing as a usable number without an explanation or support behind it. If AI gives you a cash variance, a forecast view, or a recommendation, you should immediately be able to answer 3 questions. What source did it use? What logic did it apply? And what date or version was it based on? If you cannot answer these 3 simple questions, you do not have a decision-grade output. You have an answer that sounds confident. Now, this matters because in finance, we don't operate on black box outputs. Forecasts need to be traceable, variances need to be explainable, and any recommendations need to be grounded in the underlying source data, that source of truth. That is what separates a helpful AI workflow from something that creates operational risk. So let's get into the traceability steps that we can take. If you want your AI outputs to be audit-friendly, traceability has to be intentional. The first step is to lock the source version, and this sounds simple, but it matters. If your file names are vague or constantly revised without discipline, no one will know what the AI actually used. Second, make sure that you're including constraints in your prompt. Do not leave the AI guessing which document or table or tab to reference. Be explicit. Third, require citations. If the tool can cite page numbers, rows, tabs, or even cell references, ask it to do it. This turns any vague answer that you might get into one that you can review. Fourth, log the inputs. So save the prompt, keep a screenshot, or preserve the underlying file that you used to generate an output from AI. If the output is ever challenged, you have that audit trail automatically saved on your side. And finally, preserve the output context. Save not just the answer itself, but the date, the tool, and the source that it relied upon. That is how you keep AI math auditable instead of being this mysterious thing. You know exactly where it came from. So why does this matter? Well, one of the biggest mistakes that we see teams make is assuming that a clean input automatically leads to a clean output, and it doesn't. You also need to take control of the processing phase. In other words, how the AI is working with the information that you've given it. And that means limiting the AI to only the data needed for the task. It means avoiding situations where multiple similar files are uploaded together and the model has to decide which one matters. That's not going to work. And it means separating source data from commentary, assumptions that are being made, or side notes that can ultimately distort the answer that you get from the model. And it means restating the task clearly. Is the goal for the AI model to summarize, or compare, or calculate? Do you want the model to flag anomalies? AI performs so much better when the task is narrow and explicit and well defined. The overall goal here is simple: reduce interpretation, reduce ambiguity, and reduce failure points. Now let's get into data drift. It's one of the most dangerous AI failure modes because the output often looks perfectly reasonable and like something that you can trust. The problem is that the AI is not broken itself, but the problem is that the data underneath it is no longer current, it's no longer aligned, or it's just incomplete. In finance and treasury, this shows up in very practical ways. FX rates may be outdated. Cash balances may reflect yesterday's bank file, not today's position. Forecast assumptions may have changed since you last run the model, but the schedules themselves were never refreshed. Or the entity mapping may have changed after the file was prepared. In all of these cases, the AI may still produce a polished, coherent answer, but if that polished answer is built on stale foundations, guess what? You're going to get a stale answer. You're going to get exactly the kind of error that slips through when teams rely too heavily on how good the answer sounds. So what can we do about that? Well, to manage the data drift, we can use a simple data freshness check before relying on the output. We're going to start by confirming the as of date. Every file used in AI should make timing explicit. And if the timing is unclear, the answer is already going to be suspect. Next, check whether the assumptions themselves have changed. Rates change all of the time, as we know. Forecast drivers can change. Market conditions shift, perhaps even more so more recently. A valid file from last week may already be too old or too stale for a decision that we want to make this week. Third, ask what period the AI is actually relying on. And this matters, especially when using a public AI tool, when it's looking at things like macroeconomic situations, looking at rates, or market-related questions. Fourth, you're going to re-anchor the data when needed. And that might mean uploading the latest schedule, adding current rates, or restating the date in the context directly into the prompt so it's explicit and clear. A good rule to remember is this: the shorter the decision window, the more current the data needs to be. And that's going to apply to any problem that you're trying to solve with AI. Let's get into the output risk. One of the most important judgment calls in AI is recognizing that not every output should be trusted in the same way. Some use cases are relatively low risk. Reformatting content, drafting a summary, or surfacing anomalies in data, that can be a helpful starting point. But there are other use cases that carry much higher risk. For example, recommending an action on a hedge, interpreting debt covenant language, explaining cash drivers to leadership, or producing numbers that may be reused elsewhere in the business, such as inputs to a forecast. These all require a much higher standard of review. The mistake that teams make is actually applying the same level of trust to every output. They'll get comfortable because AI sounds polished and it sounds great, and that comfort spills into areas where the stakes are just too high. So the question is not just, did AI answer the question? The better question is, what is the consequence if this answer is wrong? Now let's look at a simple framework that provides a practical way to decide, how much of a review is actually needed based upon the output from the AI tool. And different tasks will require different levels of review. So if it's formatting or summarizing tasks, those would usually start at a medium trust level. They need a quick spot check. The downside is, it's often manageable. Data extraction from clean tables can also be useful, but key fields still need validation. Variance explanation and insight generation move into kind of a lower trust zone, because this is where the AI is not just reporting, it's actually interpreting the information. And recommendations or judgments should start with the lowest default level of trust. These are the outputs that most directly influence decisions and they require a full review before use. And again, this is where we're asking the AI not just to report, but to interpret information. The key principle I want you to remember here is that the more judgment that's involved, the less you should trust the first answer that you get from the AI model. And now we're going to get into our practical exercise for Module 2. In this scenario, you're going to apply concepts from the entire module in a realistic treasury scenario. An AI tool has recommended a large FX hedge for our European subsidiaries. And on the surface, this sounds very reasonable, but your job is to slow down, track the logic back to the source data, and determine whether the recommendation that we've received is actually valid. As you work through this, I want you to focus on 3 things: where the AI pulled the data from, where the structure of the source file caused the model to misread the inputs, and why a polished recommendation from the AI model should not automatically be treated as one that is trustworthy. This is exactly the kind of failure that strong process discipline is designed to catch. Now, what I'm going to recommend here is hitting the pause button so that you can try this for yourself. Go ahead and download the Excel workbook in this module and jump right in. When you resume, we're going to cover why the output should not be trusted. Okay, you should now be ready to resume and review the solution. Okay, let's walk through what actually happened here. The AI didn't make a random mistake. It followed a consistent logic, but it applied the wrong FX rate. Specifically, it used the GBP to USD rate instead of using the Euro to USD rate when calculating our exposure across continental Europe. And because of that, the USD equivalent value was overstated, and that inflated number pushed the exposure above our policy threshold, which then triggered a recommendation from the AI model to hedge 100% of the position. So the output wasn't obviously wrong. It was, internally consistent, but it was built on the wrong input, and that's the key lesson here. This wasn't a hallucination. It was a failure of the structure of the file that we loaded. The layout of the data made it easy for the AI model to misinterpret which columns and data points to use. So, how should you approach this? Well, first, always trace the calculation. Don't just look at the final number and ask where it came from. Really dig in and understand the source of that information. Second, validate the key drivers. In this case, we know that it's currency, FX rate, and the total exposure. So those are the numbers that you want to cross-check and validate before you rely upon the output. Third, check the structure of your data before trusting the logic. If the structure is unclear to you as a human, it's going to be unclear as the AI tries to read it, and it will make the output unreadable. And finally, don't trust polished recommendations. Just because the AI recommended this and it sounds professional and it sounds like the right thing to do, it does not mean it's correct. The takeaway here is very simple. AI didn't hallucinate. It just misread the data, and your job is to catch that before it turns into a real decision and recommendation for your business. Now we're going to recap what we've learned in Module 2. In this module, we've explored how to manage our data while working with AI. We looked at how to trace AI outputs back to the source data. We talked about the idea of not having any mystery math. We also looked at how to detect outdated data or misaligned data before it impacts decisions. We looked at how to assess AI output risk and determine when to trust it based upon the types of outputs we were looking for. And then we covered our practical exercise, the hallucinated hedge, to get a more practical take on this lesson. In the next module, we're going to shift our focus to what happens after the AI has done its work. We'll start with validation, how to review the AI outputs before they influence real financial decisions. And we covered a little bit of that in Module 2 as well. Because at this stage, the risk is no longer theoretical, it's operational. We'll then look at how to identify subtle errors. These are the, not obvious mistakes, but the small inaccuracies in summaries, calculations, or interpretations that can have a significant impact. Next, we'll cover data retention and how to ensure that sensitive financial data doesn't linger in AI tools longer than it should, and how to manage that risk effectively. And then finally, we're going to bring all of that together in Module 3 with another practical exercise where you will review an AI-generated covenant summary and identify the critical errors before they reach our leadership team. This is where we move from using AI to truly controlling it. Congratulations, you have successfully completed this module. Thank you. I will see you in the next one.